Hello, my name is Patrik Yandola, and this is my EECE 2160 midterm project. The goal of this project was to create a program that could either constantly play music notes or play a game of snakes and ladders. Let's get to it. Now, when we run the program, a menu will pop out for the user, prompting them to choose between playing music notes, playing a game of snakes and ladders, or exiting the program. Let's start with playing music notes. Now, the program will prompt the user to choose a valid note between C4 and C6. Note, the entry must be valid. If the user enters some gibberish, like so, the program will keep asking them to enter a valid note. So, let's try and start with C4. Now, the program will prompt the user with the number of seconds that they want the note to play for. The user must pick a valid positive number of seconds or 0 if they wish to exit. If the user enters an invalid number of seconds, like say -3, the program will tell them that the input was invalid and prompt them to give them a valid input. So let's say the note C4 will play for 3 seconds. That was the note C4 playing for 3 seconds. Now, maybe we should do a note B5 and play it for 2. And that is how this part of the project works. The user can type exit to exit the program. Now, one of the issues raised when trying to create this was that I was continuously getting a segmentation fault error. This was occurring due to the way that I tried to write to the JP1 pins. The reason was I was using the full address twice because of the way they were combined instead of just simply using the offset for the JP1 pins. Now what this meant was that the address I was trying to write to was way too large and not present on the board, which was causing the segmentation fault error. The way I fixed that issue was by changing the base of the JP1 pins to be the offset instead of the full base address. Now, let's move on to the snakes and ladders part of this project. If the user chooses option 2, they will be taken to the snakes and ladders menu. Here, they will be given the rules of the game and prompted to choose between exiting, playing a single game against a computer, or playing 2 players, one against each other. Let's start by showing what it is like to play against a computer by choosing 1. This is the way the board is drawn to the player. The cells go from 1 to 50 in a snake-like pattern. There are letters and snakes represented as cells which have an arrow pointing to another cell. Thus, for example, cell 3, which points to 11, is a ladder. So if the user lands on cell 3, they'll be taken to cell 11. Meanwhile, cell 13, which points to cell 1, is a snake. So if a user lands on cell 13, they'll be taken back to cell 1. To make a move, the user needs to type T and enter. T stands for throw in this case, in which case a 6-sided die will be thrown, like so. In this case, player 1 rolled a 5, and they ended up in cell 5, like so. Then, computer automatically went, and the player 2, which is the computer, rolled a 1. As such, they ended up on cell 1. This is how playing against the computer works. Now, let's try playing against another player. Choosing 2 will give us 2 players. Now it's player 1 turns again, and they choose T to throw. Player 1 rolled a 4, and as you can see, they end up in cell 4. Now it's player 2 turns, and it's player 2's turn to decide whether they want to throw or exit, as both players can exit the game. Let's see what happens when player 2 types T. Player 2 rolls a 6, and as you can see here, they end up in cell 6. That is how playing against another player works in this game. Now, I've set up some rigged games to demonstrate some of the aspects of this game, like ladders, snakes, and what happens when two players are located in the same cell. So let's look at them. First up is case rigged 1. This is the game where the players have rigged dice which are set to roll 3. What this will do is on the first turn, player 1 will end up in cell 3, which is a ladder that will take them to cell 11. Let's play it. When player 1 throws, they will be given a value of 3. They landed on a ladder. As you could hear, a music effect played to indicate that they're playing on a ladder, going from a lower note to a higher note to indicate an upbringing. Also, a string came out telling the player that they were moved to cell 11. And as you can see here, player 1 is in cell 11. Now, let's look at another case, rigged game 2. The point of this case is to demonstrate what happens when a player hits a snake. The rigged dice here are set to 13, so on the first turn, player 1 will end up in cell 13, which is a snake that leads back to cell 1. Here's what happens when player 1 throws the dice. A sound effect plays to indicate that they went back to cell 1, and a string pops out telling, sorry, you've hit a snake, and tells them where the player was moved to. The sound effect goes from a higher note to a lower note to indicate a decrease. Now let's look at rigged case 3. This case is meant to demonstrate what it looks like when players 1 and 2 end up in the same cell. Here, the dice is rigged to be 5 for both players. On player 1's turn, they end up in cell 5, like so. As you can see, player 1 is in cell 5. Now on player's 2 turn, they will also get a 5, and both will end up in cell 5, which looks like this. Now, once player 1 moves away, player 2 will still remain in cell 5. So when player 1 moves away to cell 10, player 2 still remains in cell 5. Now finally, once player 2 takes another turn and joins player 1 at cell 10, you'll see cell 10 have player 1 and 2, while cell 5 went to its original state without any players in it. And finally, the last rigged case is rigged case 4. In this case, player 1 is starting at cell 41, and the dice are rigged to be 5 for both players. What this case is meant to demonstrate is the bounce back option of this game. Works like so. On the first turn, P1 rolls a 5 and ends up at cell 46. They're only 4 cells away from cell 50, the final cell. Player 1 takes a turn that is not important. Now we're back with player 1 who's in cell 46, and player 1 will roll a 5 on his loaded die. The thing is though, according to the rules of this game, you need to land exactly on the final cell, otherwise you can't win. If the player overshoots the final cell, which will happen here, because player 1 is at cell 46, while the finish is at 5. So the player will overshoot by 1, which means he will return back by 1 cell. So when player 1 throws, they'll go forward 4 cells to cell 50, and then they'll overshoot by 1, which will mean they will return to cell 49. Player 2 turns, again, does not matter. We're back with player 1, who's at cell 49. He will again throw a 5 and overshoot by 4, which will lead him to end up at cell 46. It'll look like so. This mechanic is important because it adds a lot more to the finality of the race and allows for more risk in the game, especially due to the 47 to 39 snake located right here, which can move the player's way back. And that ends the demonstration of the snakes and letters part of this project. Now, one of the issues when coding the snakes and letters part was how to create a robotic player. Uh, the issue was how to not duplicate code and how not to add too much code to create a computer player. Then I realized that a computer player is very much like a human player, and that they don't actually have a lot of say on how the game goes. The only things a player gets to decide is whether to throw the die or end the game, and the computer will not end the game, they'll keep throwing the die. So what I did was add a Boolean flag to decide if there are two players playing the game or just one, and then someone is a computer. And this Boolean check happens inside the player's move. If a computer is making the move, it will not take input, i.e. throw or exit, but will instead just say throw. And that is how the computer was created, but this game was only a few lines of code. With that, I end my demonstration. Thank you for watching. Have a good day.